Getting? Yes. Right? Any problem? No. Okay. Okay, good morning students. Welcome to the new session. So, as you all know that there are 4 fundamental forces in nature. It's a relevant topic, non-topic for us. What are they? First one, gravitational force. Second one, electromagnetic force. Third one, strong nuclear force. And the fourth one, weak nuclear force. We studied some details about all these 4 forces, right? And the first one was gravitational force. And I included that question, that gravitational part, in your 1 mark question also. What was that question? Which is the weakest interactive force in nature? You all wrote the answer well. What is the answer? Gravitational force is the weakest interactive force in the nature. And you know more about gravitational force. What do you know about gravitational force? Gravitational force is an attractive force, right? You and me are attracting. Earth and the sun are attracting. Moon and the earth are attracting, right? Even every objects in this universe are attracting, not repulsing. Gravitational force is attractive in nature. And we studied it is the weakest among all interaction, and also who invented the law of gravitational force? That also you know. Who invented? Sir Isaac Newton. So, in this chapter, chapter number 8, we are going to study in detail about the chapter, about the topic gravitation, the first law of fundamental forces. Okay. So, gravitation. Before moving to gravitation, I told you everything, every body in this universe attracts each other, right? Everything, every body means no consideration for living bodies, non-living bodies, everything in this, not only in earth, everything in this universe. So that's a universal law. In class 9 you might have studied Newton's universal law of gravitation. It is applicable for the whole, not only in this earth. Some laws are applicable for Assam state only, but some laws are applicable for India government, something are applicable for Asia continent, something applicable for the whole world, earth, but here the law of gravitation is applicable for whole universe. That is the main concern. So in this gravitation, first of all, first of all we have to find out how gravitation is related to natural properties. Natural properties means celestial bodies, terrestrial object. How it can be connected to terrestrial objects. So you know the story that Newton fell with an apple on his head and he thought about how that apple went into his head. You know that story. No, but Newton at that time thought that, is this force same? For what? The earth and the moon are attracting each other. Is that force same that the apple is going to his head? The apple is going towards the center of the earth. Both that forces are same. Newton thought like that. Understood? Moon is falling towards the earth. Apple is falling towards the center of the earth. Both are similar, right? Both are similar. Newton thought like that. Then he propounded the law, gravitational law. So, from the ancient time itself, Rohit, is it working? Yes. From the ancient time itself, many of the scientists were very much concerned about finding out different natural properties, right? So, the first scientist, Ptolemy in AD 100, AD 100 means after Christ, the first 100 year, he stated that Earth is the center of the whole universe. Earth is the center of the whole universe, and every other celestial body, all other terrestrial bodies, including the sun, the stars, are revolving, rotating around the earth. Earth is stationary, like we are, right? I told you once in our earlier Zoom meeting also, Earth is stationary and everything is revolving around us, including the sun. It's right. When as a normal observer, if you are a good scientist should be a good observer, right? So when you observe, where is the sun in the morning? It is there. And where is the sun in the afternoon? It is here. And where is the sun in the evening time? It is there. So who is rotating? In the perspective of a normal observer, who is rotating? Sun is rotating or revolving, and who is stationary? We are stationary. We are not at all moving. We are not falling down. We are not going back. We are stationary, right? Ptolemy told was right. And also, do you know the holy book of Christians? Yes, Christians' holy book is Bible. In Bible, it is written like this: Earth is the center core of all the universe, right? So, no one can tell against Bible. If someone is saying against the Bible, he will be treated as saying against the God. You know that the world population, the majority of the people is Christian. And also in that period, 200, 300, the world was under the control of Pope from Vatican. So, it was the whole world's control from Pope. So, someone is saying against the Bible means he is saying against God. It cannot be revealed. Okay. So, when we are saying against that Bible, we should have that much justification. Then only we can tell that one. But if I am saying that Earth is revolving and sun is at stationary, do I have any proper evidence or proper justification to prove that statement? Nothing. I don't have telescope. I don't have rocket to go there. I don't have satellites, right? I did not have any of the proper justifications to prove that theorem or statement, right? So, no one came forward to, okay? Yes. No one came forward to overturn that statement. Then, there came the scientist called Copernicus. Who was that scientist? Copernicus. Copernicus stated that he didn't have a proper evidence or justification, but he stated that the sun is the center of the universe. It is not all perfectly correct, but almost correct. According to when we concern about solar system, it is correct. For the whole universe, the sun is not the center, but he stated the sun is the center of the universe and all other planets, including the earth, are revolving around the sun. Then what will happen? He is saying against the God. He is saying against the Bible. He is against the normal view of a perspective. So what will happen? He was imprisoned, right? That will happen, and he was hanged. Then again, after some more years, the scientist named Kepler. Kepler could arrive at the same justification. What was that? The sun is at the center and is stationary, not moving, and we are revolving around the sun. Okay, so the first scientist who stated Earth as a center was Ptolemy, P-T-O-L-E-M-Y, Ptolemy. Then came Copernicus, that is the pattern. Then Kepler. So first one, it was Earth is at the center. Earth in Greek we will name it as Geo, G-E-O, Geo. So Earth in center, we will call it as Geocentric Theory. What is that theory? Geocentric Theory. Then the next theory is sun, Greek word is helio. Then we will call it as heliocentric theory. So who found out geocentric theory? Ptolemy. Who found out heliocentric theory? Copernicus. Then it was supported by Kepler, Sir Galileo, Sir Isaac Newton, and now also. So first of all, it was started by Copernicus, Kepler, Galileo, Sir Isaac Newton, etc., etc. And Galileo, he could make many telescopes. He could make many telescopes that were, so he could find out the planets who were rotating, right? We should see from here who all are rotating. Then only I can give the proper evidence, right? He could see that Uranus is rotating, Jupiter is rotating, then we also are rotating, right? He couldn't go there, there was no satellites or rockets available there, but he could see from here that moon is revolving around the earth, right? Around the earth means moon is revolving around the sun also, right? Then the next planet, Mars, is revolving around the earth, around the sun. Venus is revolving around the Sun. Venus, Mars, all are so close to our Earth, right? So thereby he could prove that all these planets are revolving around the Sun, solar system. That's why solar system came. Do you know the name of the planets in the solar system? These all things we will study in gravitation, because gravitation, even though gravitational force is a fundamental force, we will study in detail about the terrestrial bodies, celestial bodies, because these are the gravitational force is the force which holds all these planets and terrestrial bodies in this universe. We are staying here because of which force? Working now? Yes. So look at this figure once, okay, how it is revolving around the orbit, that I will show you. So see, consider this as Earth, okay, Earth, okay. So Earth, and I am here, and I have a gun, okay, gun, I don't know to, okay, this one may be my gun, okay. I am firing coolant, okay, I am firing coolant. So what can happen? Bullet will come out with a velocity, muscle velocity, you know, muscle velocity, recoil velocity, and when it reaches coolant, it will hit, or if coolant change from its position, what can happen? Bullet will go, and after some time bullet will also fall down, right? After its velocity, bullet will fall down. You know that, projectile motion. This is called projectile motion. Time taken to complete the projectile, time of flight. Height raise, maximum height raise. How much distance? Horizontal range, you know. And I am firing with more muscle velocity. What can happen? I am shooting Sraya now. What can happen? It will fall, it will move little more distance, right? Bullet will go little more distance. Again, I am firing with more velocity. What can happen? I am throwing ball or firing a bullet with more velocity. What can happen? More velocity. Understanding this figure? More velocity. It will go to Australia, no? Australia. Yeah. Right? More velocity. Antarctica. More velocity. America, just opposite. Anyway, more velocity. You are in European countries or South Africa, anywhere, right? Again, more velocity, a particular velocity. What can happen? Bullet will come, right? This hit my back, right? Dim. After time of flight, what can happen? Dim, right? If I am also changing my position, what can happen? Bullet will go again, right this, again, right this. It will not fall down. Understood? That's the same theory of Earth, Moon, everything. They all are revolving with that velocity. Understood? The satellites, Chandrayaan, Mangalyaan, all these things are revolving with this velocity. Suppose this bullet, instead of bullet, think it as Mangalyaan. Okay. Mangalyaan has given that particular velocity. Then what can happen? Mangalyaan going here, coming back, going here, coming back. Always it is revolving around the Mangal. Okay, that is what it is happening. Understood? Chandrayaan, we are giving to moon, then it will revolve around the moon with that velocity. Understood? And if I am increasing the speed again, what can happen? It can escape out. It can escape out from the Earth's gravitational field. Okay, so this velocity, I can treat it as orbital velocity. Velocity which it requires to revolve in its particular orbit. That's why we will call it as orbit. Okay, orbit is under the gravitational field. If more velocity than orbital velocity is given, means it can escape out from the Earth's gravitational field. Then which velocity is this one? Escape velocity. Escape means I am rescuing from there, right? I am rescuing from Earth's gravitational field. Where you can see escape velocity, rocket launching. Rocket should go out, right? In before 50 or 60 years, whenever India launches a rocket, it will always come back. Go. Projectile motion. Now it's for Pakistan. Go, come back. Right? Go, come back. What is the problem there? No escape velocity. We are not able to given that velocity. Right? Now India is good. So what? We will fire with more powder and all, it will go up. You know, rocket propulsion, conservation of linear momentum. You know very well. Right? Yes. That's why rocket is going beyond the Earth's gravitational field. Right? Have you ever seen the film Mangalyaan? If I get an opportunity, I will show you once more. There, the scientific reason, the same phenomenon is stored there. Orbit going back, like this. Then again, firing with more fuel, escape velocity, it will go from there, from its orbit. Then it will reach another, Mangalyaan, it will rotate. Right? Like that. Whenever we need, we have to fire with some fuel only. Then it will be okay. So this is the phenomenon. This is called gravitation. Why it is happening? Because of gravitational force. Because of the gravitational force. See students, first of all, these all things we have to study in this chapter. Orbital velocity, expression for orbital velocity. Then escape velocity, expression for orbital velocity. And about satellites also. You know satellites. Two types of satellites are there in our syllabus to study. Polar satellites, geostationary satellite. What is called geo? Earth stationary. Geostationary satellite as well as polar. You know polar? North pole, south pole, polar satellite. It's told. Polar satellite rotate like this from north pole to south pole. Geostationary means when I look upwards, the satellite will remain constant. That means the satellite is not rotating or revolving. Can you tell me? When I look upwards, the geostationary will remain rest or stationary. That means the satellite is not moving or moving. When I look upwards, the satellite will seem that it is not moving. Same position over my head, geostationary. That means the satellite is not moving or moving. Question. Not moving or moving. When I look upwards, the satellite is not moving. That means the satellite is not moving or moving. Not moving. It is moving because we are also moving. According to my relativity, it is not moving. Understood? Earth, I am also moving backward or front, right? But as a person looking from moon or somewhere else, I am moving with the same velocity. The satellite is also moving, right? So it is always over my head. That is called a geostationary satellite, right? If someone wants to trace my location or someone wants to spy me, what he will do? He will send a geostationary satellite. Wherever I go, it will be there, right? Wherever I go, that satellite will be there. Okay. That is called geostationary. Polar satellite, it will always revolve from polar, north pole to south pole. So dear students, your syllabus begin with Kepler. Kepler has given 3 laws. Kepler has given 3 laws. The first law is law of orbits. Law of orbits. The law of orbits states that every planet revolves around the sun in an elliptical orbit. It will tell you about the shape of the orbit, not circular orbit. The one that I drawn here was circular orbit. Ellipse, you know, ellipse. Ellipse shape is like this. Okay, something like this. Every planet, suppose planet, I am giving the name as P. Every planet revolves around the sun. So sun is somewhere here. In an which shape orbit? Elliptical orbit with sun at one of its foci. So see students, do you know that how many centers are there for a circle? One center is there for a circle. But for an ellipse, there are 2 centers. We will call it as focus. So first focus will be here. Second focus will be here. plural foci, F-O-C-I. I call it as foci, you can call it as foci, something like that. And also, these are the radius or diameters of ellipse. We will call it as, this one is of length is more, no? Major axis. We will call it as, this one, major axis. And this one is small, no? What will be its name? Minor axis. The law states that every planet revolves around the sun in an elliptical shape orbit with sun at one of its foci. You can place sun where? Any one of its foci. So I am placing sun here. Okay. Every planet revolves around this sun in an elliptical orbit with sun at one of its foci. Either here or here. I can place here also, no worries. It should be there. Understood? Yes, this is called the law of orbits. Law of orbits. Law of orbits, otherwise it's called Kepler's first law. Understood about ellipse? Ellipse shape. Ellipse is like this. Semi-major axis. Sorry, major axis, minor axis. Half distance is called semi-major axis, like radius. And here half distance is called semi-minor. Here half distance is called semi-major axis. Full distance is called major axis. Here full distance is called minor axis. Understood? So this is Kepler's first law. Can you repeat it once? Every planet revolves around the sun in an elliptical shape orbit with sun at one of its foci. Okay, this is my focus number 1, this is my focus number 2, just like center of circle. Okay, center of for circle there is only one center, but for ellipse there are two centers, like that. We will call it as focus. Plural is foci, F-O-C-I. Okay students, that's all about Kepler's first law. There are 3 laws, just statements only. 3 laws you have to by heart. First law, I guess you know it very well now. Every planet revolves around the sun in an elliptical orbit with sun at one of its foci. Understood? Okay, that's all for the class. Thank you students. Okay, I am not moving, I am just saying for online. Okay.